Hello everyone and welcome to Infinity Robotics. My name is Arman Singha and today I will be presenting the online simultaneous localization and mapping of the TurtleBot 3 and Open Manipulator X robots. As you can see, the Open Manipulator is a 4 degree of freedom robot arm that is attached on top of the differential drive robot known as the TurtleBot 3. Together, this forms a multi-robotic system that is essential to create more advanced robots in the future where they're able to perform autonomous tasks independently, move around and change their position while also being able to manipulate different objects and displace them from one position to the other. As you can see over here, the Open Manipulator actually uses inverse kinematics to calculate the necessary joint states and velocities to reach the desired location, and the end effector is then closed and opened in order to pick up objects. I have programmed these robots to operate on wrappers around inbuilt teleoperation nodes that already exist within the ROS packages for these robots. Both of these robots are open source and the entire setup process can be found on the Robotics website. As you can see here, the robot is reversing while the Open Manipulator is moving at the same time. This is due to the fact that we are using OpenCR board, which is allowing us to control multiple motors at the same time. To control the robot arm itself, we are using a graphical user interface called Manipulate. The TurtleBot has 3 degrees of freedom, while the Open Manipulator has 4 degrees of freedom for the joints and 1 degree of freedom for the gripper, totaling 8 degrees of freedom. As you can see, the robot is able to create a map of its surrounding using the LiDAR sensor, and then it is able to predict where the location of those objects is, and it creates an anti-collision zone around it, preventing it from colliding with any of the obstacles in the obstacle course. As a part of the robot operating system that we are using to control and program this robot, you can see that it is creating a map of the environment around the robot, as well as it is able to predict the location of the robot within its environment. This is known as simultaneous localization and mapping, popularly known as SLAM.